Okay, so as I promised, this is an exercise in converting one or two of those T1 and T2 interrupts to polling. And I said you have the option of implementing either or both of these using polling. I don't prefer it. I mean, I prefer to keep my main empty so that I can do some useful computation, but just as an exercise, we can do this. So remember that pulses T1 is a volatile int, right? So I can access it anywhere. I can access it in T1 interrupt, T2 interrupt, or in main. So if I want to only convert this one to polling, basically my T1 interrupt will go away. And in main, I had a while loop that, I mean, after setup, of course, right? I mean, you have your setup. And then in main, I had a while one do nothing, right? That used to be my main. And now what I can do is I could say while one, and inside that while one, I could say while T1 if is still 0, do nothing. As soon as you come out of this while loop, then it means that T1 if is actually 1, and that means that I would reset T1 if equal to 0, and then I would do plus plus uh, pulses T1, and then go back to while 1, which is, keep this thing going. And I just wait for T1IF inside this loop. If T2 interrupt happens, it's going to basically break either from the middle of this while T1IF or here at T1IF equals 0 or in the middle of this, which could potentially cause problems. We can talk about that later. But essentially this is going to give you an interrupt. You're going to come here and check if pulses T1 is greater than 3, set RB2 to 1, otherwise set it to 0, and also set pulses T1 equal to 0, so that when you come back here, even if T1 IF had happened and now you are about to increment pulses T1, T2 could jump in, hijack the PC here, set it to 0, and here the result is going to be pulses T1 to 1. Now, one thing that I want you to think about, and I'm not going to address it right now, is that this instruction in itself could be multiple instructions, right? Especially if you take pulses T1 to be a long integer. If you take it as an integer, chances are the microcontroller, the compiler might just choose one of the general purpose registers like W13 to use as pulses T1, and everyone would access W13 in that. But that might not happen. That might not happen, and you might have to just load from the memory where pulses T1 is and try to increment it. And especially if this is defined as a 32-bit variable like long int, then there are going to be a couple of instructions. You're going to do the plus plus the lower part of your pulses T1, and then you're going to add the higher part of pulses T1 plus 0 plus carry using the add C instruction, right? And of course, loading 0 into W0 could be another instruction. So this could be a couple of instructions. And if it happens in the middle, then things could be calculated in the wrong way. So, I mean, you could have plus plus L done in the middle, and then this jumps in and sets it to 0, and then the high part is going to be added to the carry. Alright, so instead of having 0 for pulses T1, you could end up with 1, 0, 0, 0, 0, right? So this is the high part of pulses T1. This is the low part of the high pulses T1. This makes it 0, but you were in the middle of this and this created a carry. Let's say before that you were at, I don't know, 23 FF, right? So when you incremented L, FFFF became 1 and you were going to make this 24 0 0 0 0, but because this happened in the middle and you expect your pulses T1 to be 0, this add C gets executed and C is popped from the stack in the status register, so your pulses T1 will be actually 1 0 0 0, which is equivalent to the decimal 65536, right? It's supposed to be 0, but it's 65536. So that's one instance in which this could give you wrong results, and that's the price that you have to pay. So maybe for most of the people implementing things in polling inside while loop in main, waiting for that T1IF to go to 1, maybe that's easier to implement, but then you have to be careful about cases like this that might happen, and that's something to be aware of. Although now that I'm saying that, I can imagine that if you define this in our implementation, both T1 interrupt and T2 interrupt were of the same priority, so T2 wouldn't interrupt T1. But if you had defined T1 interrupt as a lower priority interrupt compared to T2, then the same thing could have happened. So you could potentially have these problems in interrupts as well. Okay, so this is scenario 1, in which you only convert T1 interrupt to polling, keep T2 interrupt, and things are going to work out well. Now consider a different scenario. So I'm dividing these into 3 different scenarios, and this one keeps its T2 interrupt intact, and things are going to be similar to what you have down here. Now if you only want to convert T2 interrupt into polling and keep T1 interrupt intact, then essentially your while 1 loop then becomes while T2 IF is still 0, do nothing, and then the rest of it would be exactly the same as what you would do here, right? So you just move the body of your interrupt down here and then go back and do this while 1 forever. Okay, so that's sort of straightforward as well. And again, you could potentially think of cases in which now T1 interrupt might mess up things. So pulses T1, setting it to 0, has 2 parts, the low part and the high part, if pulses T1 is defined as a long int. And then in the middle of setting this to 0, you could have plus pulses T1, and that could again potentially mess things up with the value of T1. Now, if you want to do the polling for both of them, then there are 2 different things that you have to wait on. You have this while T1IF double equals 0, do nothing, and then you have this while T2IF double equals 0, do nothing, right? So what is the solution? How are you going to implement both of them as polling? So one bad solution would be this. It's actually not a solution, at least not a good solution. So one solution would be to say while T1 IF is still 0, do nothing, and then take care of T1 IF stuff. I have one extra I here, one here. All right, and then do plus pulses. And then after that, you could say wait for T2 IF becoming 0, do nothing, and then check to see first set T2 IF to 0, and then check to see if P is greater than whatever value, do this, else do that, and then set pulses to 0. Right? Now, this is a terrible solution because here you wait for the first pulse from the external signal to arrive, and you increment it, and here you're going to enter this while loop, which is going to take 16,000 instruction cycles or so if you're waiting for 1 millisecond, right? So you're going to completely miss any activity on T1IF that might occur. So this is a this is not a solution. This is terrible. So what I want you to do is to pause the video now, think about a solution, try to write down your solution in which you're doing both as polling, but fix this problem, and then listen to the rest of it, watch the rest of it, and see what my solution is. Okay, so pause now. All right, so the solution, I don't know if you got it or not, but the solution would be something like this. So you have basically two conditions that are asynchronous. Each of them could happen at any time. So basically my polling loop is going to be while T1IF is still 0, right? And I'm syntactically this is wrong. I have to have some bits dot T1IF. And so this is the logical AND, not the bitwise AND. And T2IF is still 0. Do nothing, right? So this while loop is going to wait for as long as both of the events, none of the events have happened, right? The while loop is going to break. Wait a minute, should I say or and? Yeah, and is okay. So when I break out of this loop, then either one of the two things, or maybe even both, have happened. So I should say if T1IF is 1, then do the stuff for T1IF, including T1IF is set to 0, and then do the plus plus. And I'm not going to say else, right? Because both of them might happen at the same time. So I'm always also going to check for if T2IF is 1, then set T2IF to 0, and then check to see if P is greater than something, do that and reset. Pulses is going to be 0, and that's the end of if. And then go back up here to wait for the while loop to tell you if either of the events have happened. So a little bit, hard to digest, but if you really think about what you're supposed to do and think about different scenarios. So I guess the best way to understand this would be to assume that none of T1 and T2 have happened, and then T1 happens but T2 hasn't happened yet, and then what do you expect to do? And then go back and think about now T2 has happened but not T1. What do you do? Or you could say both of T1 and T2 happened at the same time. What do you want to do? And here, I guess the behavior of the program would change if you change the order of these two, right? If you change the order of these two, let's say P is right at the cusp of making it to the number of count that you had, right? So the above implementation, if you put T1IF first, you are going to consider that as the target frequency met. If you put this one, T2IF, before T1IF, then you barely miss it, and you barely make it. In fact, you miss it, and you're going to reset P to 0 and then do plus plus. But I mean, these are minor things that you can think about in more advanced settings. Okay, I'm not going to write the code itself. Maybe I can ask you to do it and simulate it and see if you get the results that we expect. So the result here should be similar to what you saw in the interrupt version, and hopefully it's going to work. But let me know if you want, and I can sit down and implement it all 4 versions. So version 1 is the one that I have posted already, and the last video was about it, which is both T1 T2 are interrupts, right? Version 2 is T1 interrupt, T2 polling. Version 3, T1 polling, T2 interrupt, and version 4 is this last version in which both of them are implemented as polling. And of course, needless to say, once you want to implement, for example, T1 as polling, right? So you have the T1 interrupt, right? So first of all, you delete this, and also in setup, when you have T1IE equal 1, you delete that as well, right? Or the IP. IP would be would not be looked at if T1IE is not set to 1. But I mean, these are the details that I skipped over. Okay, thank you.